Yes, his screen is visible. Yes.
Okay, okay. Okay then. Thank you, Shagota. Yeah. So to start with, just let me where I can see participants. Okay, anyways, so any idea what machine learning is? So you nowadays you are hearing one thing, not nowadays, it's quite a lot of time. Machine learning. What is machine learning? How much idea we have about machine learning? What is machine learning? Can we have any uh, volunteer who can answer this? So I don't need any correct answer. There is no nothing wrong, nothing right. I just want to understand what you know about machine learning. So that's it. Am I audible?
Yes, yes, you
Yes.
are.
Yeah, yeah, yeah. Yeah. Can you tell me what is machine learning? You can type as well. Anyone? Anyone? I'll
So
take two.
it's a kind of an algorithm through which
Okay.
automation can be done.
Okay. Okay.
So there will be what we call training data for the machine to actually know what is the input and the output. From that, it will learn.
What is the input and output? Okay. So first one was Cheyenne, and second one, what's your name?
And it
Okay, Cheyenne Deep. Okay. Okay. Uh,
So basically, it's to uh,
hmm.
um, define maybe it's to make a machine capable to imitate the
Okay. Okay. Okay.
the intelligent behavior or yeah.
Okay. Okay. So I will take all the answers. Okay. So you are saying machine capable, make machine capable, right? Make machine capable
Yes, to
well,
imitate
to
intelligent behavior.
mimic intelligence. So I'm just cutting this little short, the same meaning. And then this is something training the machine, training the machine with data. Okay. So any these are uh, a summary of the answers. Uh, what you were saying now, I will try to give you. I'll try to give you one story. Okay. So now, so that the things are very much clear to you. See, so there is an employee who got a new job. Okay, got a new job. His office space. So this is his home, and this is his office. Okay, there are two ways to reach out there. Two ways. This is route one. This is route one, and this is route two. Route two. Okay. So first day he took route two. When he started going office, first day he took route two, and he observed that it is taking 1 hour 15 minutes. 1 hour 15 minutes on day one. On day two again he took route two. It is taking 1 hour 20 minutes. 20 minutes. Means route one he took route one again. Third day he took route one then, and he observed that it is taking 45 minutes. 45 minutes. Before he again took this route, it took 55 minutes. What do you think on day 5, that is on Friday, Monday, Tuesday, Wednesday, Thursday, that is on Friday, which route the employee will take? He will take
More likely root 1.
Root 1, right? Root 1, because this is a human. Human is collecting root 1. Human first, what human is first, what it is doing? Human started some activity, going office and gathering some information, that how much time it is taking, and that information slowly converted using the intelligent mind, that that particular information is turning into experience, right? Experience. Based on the experience, the human is taking the decision of the similar activity, same activity. Am I making sense? You understood? So first day and first 4 day, the human is collecting some information. That information, with some intelligent mechanism in our brain, in human's brain, that information turning into experience. Based on experience, it is taking next step, next route, or next decision, next decision of next activity. That is how it works. Okay, so now, so if I try to put this diagrammatically, how I should put this. So activity, and then information, and then this is some thought mechanism in our brain, right? Thought, thought, thought mechanism in our brain. So information is turning, it is turning information into experience, right? Experience. From experience, we are taking the decision, decision decision of next activity, next activity. Okay, now see, machine learning starts, for now I am not going into deep self learning mode, I am not going into that self learning mode. Now I will start. So machine starts from information, basically. Okay, machine starts from information. So machine gathers the information is nothing but data for machine. This is for machine, this is for machine. Information turns out to be experience. Sorry, I should use same color. Information or data, right? This is equivalent. This is step 1. And step 2, it is turning into an experience. Now experience machine doesn't have its own brain, right? Like us, we have a we have a super qualified brain with us. We even don't know the power of brain. Nobody knows. It's immensely powerful, right? It can take decision, it can turn information into valuable experiences. Okay, based on that we can take decide our next action. So in similar manner, machine, it is turning into experience as well. That experience, how this process is go. So from 1 to 2, how it is coming, the way is machine learning. Okay, so machine learning actually taking input as this data and turning that data into an experience. Now I should say this experience, I should say I am turning this experience as ML model, machine learning models. Okay, machine learning models. And machine learning models we need to invoke. Now instead of decisioning, we need to invoke this. Invoke, and we will get the prediction or the decision, next activity decision or the prediction. Prediction. Now I will explain this word prediction as well. Okay, so far any question? This is very fundamental thing. Just let me know if you understand, can relate or not.
Yep, makes sense.
Okay. Others? Who answered this? I
Gaurav. My name is Gaurav.
Gaurav. Okay, Gaurav. Thanks for the response. Others? Vinay.
No, sir.
Okay. Who was that?
So join row.
Okay, join row. Okay, where you have doubt? You tell me which part you are unable to understand. Let me know. No question is silly. Okay, please go ahead. Where you don't understand, this is very important actually. Jointo?
Sir, it's clear, sir. The way you make understand, up to now, I have no doubt, sir.
Okay, you have okay, no doubt. Okay. I thought that either way. Okay. So assuming there is no other doubt, I am just moving on. So basically, information or data, it is taking going into machine learning model as input, or machine learning algorithm as an input, and that machine learning algorithm creating a machine learning model. Okay, we need to invoke that. We are going to predict using that. Okay, this is the step. So now next step. Okay, what are machine learning models? What kind of machine learning models? Kinds of machine learning models. So there are three types of machine learning models. First type of machine learning model equal to nothing but a function. Y equal to fx. That's it. Y equal to fx. It's a functional relationship. Okay, this is one kind of machine learning model. Kind one. I am coming into the name shortly. The second kind, x, only x is there. X is transferred to maybe see pattern in x, maybe pattern in x. This is second kind, pattern in x. And third one is reinforcement learning. Okay, reinforcement learning, I'm coming, I'll describe little bit, but it is out of our scope. Okay, reinforcement. So I'll definitely answer this as well. What is this reinforcement? Reinforcement, MEN, reinforcement. Okay, y equal to x. So now y equal to fx is nothing but the functional relationship. So you have data. So whenever your business problem is to predicting something, like you want to predict uh, you want to predict an employee will churn or not, will churn or not, will churn. Okay, let me take a step back. Okay, because so here in y equal to fx, this particular case, how the data will look like this. Y, there will be one y, and there will be different x's, x2. So x is called explanatory variables and y is called response variable. So there is a easy name of this. X are called independent variables, and y is called dependent variables. There should be only one y. Okay, so I have multiple rows of data where y and x relationship are there. So multiple rows of data. So our objective is to create a machine learning model where y is getting predicted via inputting x, right? So basically we are creating a functional relationship between y and x. The function may be something like this: 2x1 plus 3x2 minus 0.5 x3. This is also one functional relationship. So basically, from this data set, this is the data, right? This is data set. From this data set, on top of this data set, we are applying machine learning model, and we are machine learning algorithm. We are getting this machine learning model. This is the experience, right? Machine learning model. Okay. So where y is present, these are called supervised machine learning model. Supervised machine learning model. Okay. Y is present. These are called supervised machine learning model. Okay. So I'll give you some example. The example number 1. Example number 1. Employee is churning out of the company or not. So based on previous performances, so any supervised machine learning example you have in your mind? I want to know what class knows about the supervised machine learning model. If you heard from somewhere, or you read something, or you already know this, so I want to know any supervised machine learning problem, practical problem, real life problem, example. That's it.
I mean,
I'll take
credit risk models.
very good. Who answered the can you please take your name as well?
Gaurav.
Gaurav. Okay. Okay, I'll try to remember your voice, Gaurav. Credit risk model. Credit, what it actually does? You tell for the class what it predicts, and using what is my y and what is my x. 2 or 3 x example of x for credit risk.
So a very known example is probability of default model. So wherein
Okay.
y is the probability of default, and then x could be various factors like income, industry,
Very good.
job status.
Okay. Basically, we are predicting whether a particular customer will default or not. And the variables will be customer demography, customer age, income, okay, credit score, own home or not, okay, occupation type, other credit card default history, credit card default history, etc. So these are the typical x variables used in this credit risk modeling. So what we are predicting here, my y is default or not default? It's 1 or 0, default or not default. And what are my x? These are my what are my independent variables? Age, income, all the demographical information of the customer, okay, and some other thing as well. So it can get little complex in terms of variable space, so I'm not going into deep. Okay, does that explain, Gaurav, for the class, or you want to add anything?
No, but that's fine.
That's fine. Okay, credit risk, very good. Okay, another example for supervised modeling.
Another example is if we want to relate sales within advertisement
Okay.
done.
Okay, sales versus advertisement. Okay, it's a market mix one. This will be little bit difficult to difficult for, as a first example. Okay. Because the thing is very abstract. Okay, any other example from anybody?
Sir, this is Ashish.
Okay, yeah.
Yeah, actually, I'm wondering what is the difference between this and the regression? Because you are saying that this is y, prediction of y from some known x.
Okay.
Because one example that I have in mind is the cancer prediction models.
Okay. Yes.
You feed in some images of cancer. These are images which are annotated by the doctors, saying that this is cancer, this is not cancer.
Okay.
So then, yeah, then probably I don't know whether they are using any other data apart from 1, 0.
Okay.
And then you feed in a new image. The machine learning models are able to predict whether this is cancerous or not.
Yeah. I'll tell you. Good,
So
good,
the
good.
first, the annotated, this thing is known as the ground truth, and then the prediction comes.
Yeah. So I'll explain this. Yeah,
Yes.
just hear me out. So see, cancer prediction is a very good example. So given the image of the test, so whatever that may be MRI, that may be CT scan, I don't know. There are a lot of, there can maybe lot many images, right? So images are basically nothing but, for computer, images are nothing but some pixels, right? Some pixel values. So basically some pixel values, right? For images, if you decode the images, there will be some RGB codes, pixel values, and using those pixel values, we are, these are my X space. This is little complex, the things, this is called, it is a special branch of machine learning, the special discipline of machine learning, you can say. This is called computer vision. Okay, so here, using, so instead of a doctor, a model, model is trained with the experience of a doctor, who can diagnose seeing the image. So image is nothing but the pixel value. Those pixel values are input to the computer, to the model, and that particular model will predict whether it's a cancerous or not, one or zero. Okay, this is how. So here we have, these are pixel values are my independent variables, and this is my 1 0. Again, I am emphasizing this 1 0. This is my dependent variable. Okay, this is a good example. Okay, moving on. So I am just taking another page. Hmm. So ML supervised definition is present present present. So y equal to fx. Couple of examples are credit risk, where default prediction uses customer demography, customer data, transaction history, etc. Transaction history, etc. Trans history, etc. Right? History, etc. Number two is what you say? Cancer prediction. Cancer, whether cancer or not. Cancer or not. 1 0. This is also 1 0. Default or not. Say images. Any other easy example? Okay.
The probability of buying a house or not.
Okay. Probability of buying a house or not. Very good. Who was that?
Angela Sarkar.
Okay. Probability of buying a house or not. Buying a house or not. Buying a house or not. House. So 1 0. So using the home location, that may be locality, number of rooms, age of the entire property, so distance from the market, distance from the railway, distance from the airport, etc., right? Distance from the market. So based on this, we can create a model. So in fact, many sites are using this kind of models as well, buying a probability of buying a house or not. Okay, so
Yes.
this is another example, very good example. So, and I am giving you one example, maybe salary prediction. Okay, so maybe I'll give you. So order complete, any, you are giving any order completion time prediction for telecom, maybe for telecom. So you are placing an internet order completion type. So you are placing an internet order. So internet. So you bought an office. You are starting an office, one business. You set up. You have a huge setup. You need the huge setup of internet. So you ordered that. How much time will it take to will it take to complete? So this is important for the internet connection provider, because they are going to commit, sir, I will be completing your order within 5 days, within 10 days, or 1 month. right? If they are saying it will take 5 days and they are taking 1 month, your business, you will charge a penalty now for 25 days penalty, because they are violating their promise, right? So that's why this order completion time prediction for telecom at day zero is very important. Okay, so what will be the co-variables? What will be the independent variables? The independent variables: order type, complexity. Complexity means complexity, available resources in the locality, resources in the locality, etc., etc. Many things. The variable space will be complex, but this is a supervised problem where we have y. So now order completion time. So now tell me, what is the difference between 1, 2, 3, and 4? Can you tell me what is the difference between 1, 2, 3, and 4? Difference. Difference between 1, 2, 3, and 4.
The type of independent variable.
So this is
I'm not
dependent,
sure.
right? This is dependent.
Yeah, I mean the x variable
No, no,
in
no,
each
not
cases.
okay. So those, but 1, 2, 3 has something in similar, and 4 is odd man out. So
One
what is
is
the
logistic, one is linear. So this will be a
ah?
continuous variable. The other
Okay,
three are logistic.
okay, very good, very good. Who answered this?
Syandit.
Okay, Sandeep. See, here order completion time is nothing but it's a continuous variable. It's a numeric variable. Rather continuous, I should say numeric variable. So it will be 1 day, 2 day, 3 day, 5 day, 10 day, 1 month. I mean, that means 30 days, 60 days, right? Here we are predicting 1 or 0, 1 or 0, 1 or 0. Here we are classifying the facts, right? Classifying whether it's a cancer or not, it's a buying house or not, it's a credit risk, it's a default or not. Okay, and here we are predicting what is the amount, the quantity, what is if you want to predict your salary. So it's this experience, this education, this is the country searching for job, what will be the expected salary. Okay, salary, it's a continuous variable. So here y variables are categorical, and here y variable is numeric. Okay, so just remember this difference. This is super. And for unsupervised, so okay, sorry, for the next, so is this clear, the difference? The difference, and remember this difference, please. Okay, this we will coming shortly, coming back within this difference, with this difference. Now this is supervised and this is unsupervised. There is another class, unsupervised. Unsupervised, what is unsupervised? Unsupervised means y is not present, that's it. Y is not present, not present, only x are there, and using x data you need to find out some patterns. Okay, and reinforcement learning is mix of both. Reinforcement learning is something, it's used in gaming. Like in gaming, you are playing online chess, you are playing online any kind of game, that may be Dota or whatever. There are many games online, right? So reinforcement learning is used to create those games. This is one example. Okay, reinforcement learning is it's a supervised and unsupervised both. It's a mix of these two. Reinforcement. Okay, so I'm not diving into details. For unsupervised, y is not present, and supervised, if y is present, closing your eyes, you can decide that it's a supervised machine learning problem. Okay, okay, and just do remember, in supervised machine learning model, we provided two examples where y variable, that is my dependent variable, is binary or categorical, and the variables are numeric. The y variable is numeric. These are two specific classes. So let me regroup this, summarize this. Okay, now ml supervised, supervised, unsupervised, reinforcement, reinforcement. So you able to understand my handwriting, right? Give me an answer, please. If it is not, I will go slowly, please.
Yes, sir.
So fine, fine.
Okay, okay, okay. Thank you. So supervised, unsupervised. Okay. In supervised, supervised, Y is present, right? Y is present. And now Y can be categorical. Categorical means that may be class A, B, C, D. Fraud, not sure. Churn, not sure. These are three classes, right? Default, not default. These are classes, categorical. Call, and this can be numeric, like salary, rainfall. Okay, share price, numeric. If it is numeric, Y is categorical in numeric. If it is numeric, then it is called regression problem. Regression problem. Regression problem. Regression is a kind of class supervised classification. Okay, is supervised ML regression where Y is numeric. Clear? And if it is Y is categorical, it is called classification. Classification problem. Classification problem. Now you understand the class, understand the segregation or not for supervised machine learning problem. Just let me know. Okay, I'll take a pause. Think and let me know if you understand or not. If you don't understand, I can repeat. No question is silly. Please ask.
Hello. Excuse me, sir.
Yeah, go ahead.
Hello. Yes.
Yeah, go ahead.
In the numeric, is there a regression? Can it be logistic regression and the other?
Okay. Okay. I am registering your question. I will answer. Okay.
Yes. Yes.
Okay. Yeah. Any other question? Okay. Hopefully there is no question. I am assuming that you guys are understanding. Okay. Now, why categorical and numeric classification problem and regression problem? Now, next. What next? Now, what are the type of algorithms we have in classification? Okay. Type of algorithms. So first classification algorithm I will take, it's called logistic model. Logistic model. So it is not a regression. So in many blogs, many books, so you can see the term logistic regression. So though it's a very useful thing, so that term became very popular, but it's not the actual one. It should call logistic models. Everywhere I mentioned in the email as well. Hopefully, I mentioned logistic model. If you observe that, I don't know, Ashish. Okay, this is the first
Yes. Yes.
example. This is called logistic model. If someone is terming as logistic regression, it's the same thing, but it is not a regression. It is a classification problem, a classification algorithm. Okay, clearly that clearly put in your mind that it is not a classification, not a regression algorithm, though it terms regression by many people, but it's not. Okay. Now, logistic model number one. Number two, probit model. Probit model. Okay. Number three, random forest. These are Okay, sorry, not random forest. Number 3 will be decision tree. Decision tree. Okay. Number 4 will be random forest. Random forest is nothing but collection of decision tree. Number 5. Number 5 maybe boosting. Boosting is a class of algorithm. Okay, boosting is a class of. So I will give you one example of boosting algorithm. Maybe gradient boosting, grad boost, boost, XZ boost, etc. Okay. Number 6, neural network. Network. These are some algorithms in classification algorithms. Okay, these are some classification algorithms, and there are some algorithms which we can. I wrote random tree. My apology. This will be random forest. Random forest. Random forest. Okay. So logistic model, probit model, decision tree, random forest, boosting. Boosting is a family of algorithm. Okay, algorithms. So gradient boosting, grad boost. In short, we can write grad boost and XZ boost. These are two examples. There are many more in boosting. Neural network. Neural network is a special kind of thing. I don't know whether you are going to learn in this course or not. Okay, neural network. So and so this is where Y is categorical. The master thought is the master information is Y is categorical. Categorical. Either 1 0 1 0 or 1 2 3 or ABC. See, 1 0 is also a numeric, right? 1 2 3 is also are also numeric, but there. So whenever we are putting 1 2 3 or 1 0, there we are not considering any order between them. We cannot say 1 greater than 0 or 0. See, this is just a symbol to make computer able to compute. So that's why these are symbol. A stands for 1, B stands for 2, C stands for 3. In that manner, you can assume. Where here A default stands for 1, non-default stands for 0. You can assume that as well. Get my point? Okay. So Y is categorical. Now regression. Regression. I will give you some example of regression problem. So regression basic one is linear regression. Linear regression you will learn at first. Linear regression. Linear regression. Linear regression. Someone was mentioning, I think Ashish was mentioning where linear regression is falling. Linear regression. Number 2, regression trees. Regression tree. Number 3, random forest regression. Random forest regression. See, there are many more. So these are some examples. Okay. So in classification, there will be many more. There are many more algorithms. Okay. So these are some examples to help you out to start into to enter into this world. 3, 4, 4. Boosting can be used for regression as well. So I'll give you one example. XZ boost. XZ boost can be used for regression problems. XZ boost. Extreme gradient boosting. This is called extreme gradient boosting, starting with X. Okay, it's a very renowned algorithm. 5, neural network. Neural network. Neural net. Neural net can be used for classification and regression both. Okay. So these are more or less a span of supervised machine learning algorithm where, and here Y is numeric. Here Y is numeric. Y is numeric. Okay. Y is numeric. Now tell me if any question.
Sir, can you give some examples for this classification problems
Yeah,
or
sure. I will.
probit
Couple of
and
problems we already discussed, like default or not. You
mm,
understood that? That is one
yes,
classification problem.
yeah,
Okay.
yeah. There's
And
many ones. One simple example will be fine.
yeah. So another example, one simple example I should say, whether an employee will leave the company or not. 1 0.
Yeah.
Okay. Okay.
Uh,
Whether
for
whether this person buy jeans or not next month. Whether this person will buy television or not. These are these are simple examples. So anything where there is a decision, yes or no, yes, no on. So there may be A, B, and C, A, B, C, B. There may be 4 classes. Wherever you are trying to predict something, which is classification. So, so regular example I can give. Real life example. Churn is the most. Churn means so you understand. So you understand employee churn, or I can explain. You understand that?
yeah, I understood. Sir,
Okay.
I was referring to this boosting and random.
Okay. You are referring to this boosting and okay. So
Yeah,
these are different algorithms. So problem, so classification, so that default or churn problem can be solved using boosting as well, using random forest as well. These are different algorithms. I think
yeah.
you will learn these things in your course. Random forest you will definitely learn in this course. Okay, is that included? So you have that curriculum. It is in,
Right in module 1, we don't have. I
okay.
think so.
A decision to you have, I believe.
Sir, right now we have logistic model.
Only okay. Right now you have only logistic. Okay. So see, if you learn one any of the model in a concrete manner, 50% of the rest you will know, because the model is nothing but it's a one liner thing. Okay, so one liner the model will be done. The rest of the things will be similar. For classification problem as a whole, the rest of the pieces of your codes or of your solution will be same. So only one liner. Say whether it's logistic, it's probit or decision tree. So one liner change. Okay, maybe couple of line change, couple of lines change in your code. Okay, so you learn logistic model. This is widely used. First, after that, you jump into those things. That's not a problem. Okay, random forest is nothing but collection of decision trees. Okay, so I'll tell you. So, so you want example of real life business problems, or you want to
Yes.
understand?
So that will
Okay,
be
okay, okay. Okay, so first one is the default, default or not, as we discussed. Okay, second one, you know the independent variables, customer data and transaction, customer data, different data, customer data. Second one, churn, employee churn depends on so employee salary, competitive salary in the market of same experience, competitive salary. If someone is drawing 5,000 and with same educational background, same experience, in market there are jobs available with 25,000 salary, then will he or she he or she will continue with the organization? Definitely the person will turn out, right? That competitive market salary, okay, current salary, market competitive, so last promotion, etc. There can be many things, promotion, etc. Okay, other, so this is churn. Number 3, I'll try to give you an example. Customer will buy a product or not, customer buy or not, customer buy or not. So customer previous choices, customer buying history, purchase history, demography, Yeah, what is the age of the customer? If age of the customer is above 60, the customer will not definitely buy a fancy iPhone, right? But if the customer's age is near 20 to 22, the customer is there, and his financial condition is good, can buy a iPhone, right? So this kind of classification thing the businesses are using nowadays. Hmm. So with each and every data, how whom to target, whom to not. If the customer is probably customer, if the customer will buy probably, then the advertisement will pop in customer's window. Wherever customer is using the social media and all, you will see that start seeing those advertisements. If you are prone to buy those things, okay. Customer purchase history, age, 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 family. So these age, family, customer data as a whole, this age, family income, family, these things, personal income, own home or not, these are in total called demographical information, demographic information of the customer. Okay. So customer will buy or not. Number three, number four, uh, will rain or not? Will rain or not tomorrow? So weather, in weather forecast, this kind of thing can be used. So whether tomorrow there will be rain or not. So suppose there is a construction is going on. In that construction, there will be a huge what I should say, huge piling up of concrete. They are creating concrete tomorrow. Okay, the whole roof. So if there is rain, that will hamper. Suppose L&T took responsibility to create a bridge. 50% of the bridge concretization will be happening tomorrow. So if there is any rain tomorrow, then that will hamper the work. So they can use this kind of models, whether this will rain or not. But in practical we don't use that, because we have already forecast, weather forecast ready with us. But this can be done. This can be say, we can say this as a classification algorithm. Okay. Okay, like cancer detection, cancer or not, or cancer or not. Any other example anyone want to add? Cancer or not? Any other example? So images will be input. Any other examples? Anyone have? Okay, anyways, so we will solve one classification problem. I am jumping into that. So now we will learn logistic regression today. Not logistic regression, logistic model today. Okay, logistic model today.
I have a question. Yes.
Yeah, please. Please, Saurabh.
Yeah. So let's say you have identified. So let's say you have identified the problem is classification model related problem. So you mentioned multiple algorithms. So what is the criteria to pick one algorithm from
Okay,
all
okay,
the
okay,
mentioned
okay,
mentioned
okay, okay.
algorithms?
Okay, so this is too early for you to get that answer. So answer the answer is experience. The answer is trial and error. There is no thumb rule. If there would have been any thumb rule, long back, we might got some readily available tools which will decide itself, using the data, which will decide which algorithm will be best fit, and accordingly it fits you the base model. There is no need of doing these things. There would have been no need for doing these things, right? This is too early. So the answer is, it's based on experience, based on data type. Like there are some thumb rules as well. There are some thumb rules, like if your independent variables are independent among themselves, then you can use naive base. This kind of thumb rules are there. Okay. So for now, we need to decide whether it's a classification or regression. Accordingly, we need to trial and error multiple algorithms. So based on performance measurement, we need to decide which model will be best fit. Does that answer your question, Saurabh?
Yeah, I got it. Thank you.
Yeah. Okay. Okay, now logistic model. Logistic model. Before that, I will just give you one small introduction to linear regression, because I was hoping that you will be listening to the class of regression, but linear regression is needed to understand logistic regression. Okay, so linear regression is nothing but y equal to mx plus c. Mx plus c. M is your one constant. So let's not make it complicated. Ax plus b. Ax plus b. A is your coefficient of x and b is a constant. This is called simple linear regression. Simple linear regression. And y equal to, there may be multiple x variables, definitely a1 x1 plus a2 x2 plus a3 x3 plus b. This is called multiple linear regression, MLR, multiple linear regression. Okay, so this is, so here y can be anything between minus infinity to plus infinity, based on the problem. Definitely y can be anything. Okay, y can be negative, y can be positive. So based on the problem, obviously if you are predicting family size, then it cannot be negative. If you are predicting if you are predicting salary, it cannot be negative, right? So there are some business driven range will be there, but in general y can take anything. Y can be on real line, any number. Y can take any number for linear regression. Clear? But for logistic model, what we are trying to do, we are trying to y equal to, let's say this is logistic model, y should be between 0 or 1, 0 or 1. Instead of that, we are converting this problem. Y basically comes, y basically should be between 1 to 0. 1 to 0. We are transforming this problem to this. Y is 0 and 1. 0 and 1 predicting 0 and 1 using some equation will be difficult, will not be possible. Exactly 0 and 1 will not come. So that's why we are transforming this problem to y is falling from 0 to 1. Okay, so you are providing input in terms of 0 and 1, but what you get as a result, that will be a number. The model will be giving you one number between 0 to 1. That any number between 0 to 1, there is a term. What it is called? Any number between 0 to 1, we can term that as anyone, any number falling in this range. What we can call this?
Probability.
Probability. Good. Probability. Okay, probability. Now I am just simply transforming this. So how should I start? So y equal to ax plus b was linear regression. Now y should be between 0 to 1. So to make this fall this y within this range 0 to 1, one transformation is needed. That transform, what is that transformation? That transformation is log transformation. Log e base, that means ln y by 1 minus y equal to x plus b. Nothing will change. Y equal to x plus b was linear regression, and logistic model is this. This is logistic model. That's one transformation, log transformation. Okay. Okay. So now let me derive the equation. Okay. Not derive. I'll start from here. I'll not derive. So y equal to x plus b. This was linear regression. Logistic ln y by 1 minus y equal to x plus b. This is logistic model. Logistic model. Okay. So I will find out. I will write this in terms of y. Okay. Let's try this. Y by 1 minus y, e to the power x plus b, e to the power x plus b. Right? We know this, right? E to the power x plus b. From our 11 12 we learned logarithm. From logarithm class we need to remember this. So y, so now I am reverting this 1 minus y by y. Now naturally this will be reverted as well. There will be a minus. Okay. 1 by y minus 1 equal to e to the power x plus b. Now 1 by y equal to 1 plus e to the power minus x plus b. Now y equal to y equal to 1 by 1 plus e to the power minus x plus b. This is the equation of logistic model. Okay, in terms of y. You can see easily. You can provide any number to this independent model. You can try any number. See, it will always fall in. Y will always fall in 0 to 1. You can put any number in x. X is independent variable. You don't have any control. X can be salary. X can be anything. X can be rainfall. X can be salary. Anything x can be. So we don't have any control over x. We cannot bound x. So if you put any value in x and you see the y value will always fall in 0 to 1. It will not cross that. Okay. Now so any question is till now?
Just a small question. So in logistic model equation, can it be e raised to power minus a1 x1 plus a2 x2
Yes,
kind of?
yes, absolutely.
Okay.
Absolutely. Absolutely. And it's a good point. If that is, this can be e to the power minus a1 x1 plus a2 x2, same thing, plus a3 x3 plus b. Yes, this can be a logistic model. So I provided the example with single variable. So multivariable, multiple independent variable can be there. Good question. Okay, now I am moving on. So let's do one thing. Let's create a logistic model ourselves in Python, okay, and learn it together. So uh, so I have taken a blog, simple blog, and I took the example they solved there, and I created a code, wrote, I modified little bit that code, and I provided that code to you. So you all downloaded that data, full data or small data? Anyone? Everyone?
Most of us have small data.
Okay, most of you are. Anyone who doesn't have data, let me know. Okay. It's a very silent class. No one is answering. So I'm assuming that everyone has this data. Okay, that data. So I'm just opening that data. So I will take a bottom-up approach. So I'll not teach you the theory first and then practical. I'll take the reverse way. So let's do the practical. During the practical, let's understand the steps of steps, right? So now, where is this? Learning center. So just open Python. So I have shared one code as well. I have shared one code with you. Okay, just open Python. If you are facing any problem in opening Python, if you have any doubt, just let me know. This is the time. Let me know if you have any doubt. So let's do this together. Okay, that's my request. Just open Python and open this code. This code is logistic model based sample code. Okay, I have shared that already. So you are using Jupyter Notebook, Ashish?
Yes.
Okay, you are using Jupyter Notebook. Just open. So open this code in your Jupyter Notebook.
Can you share this code?
Code. This code is not there.
It was shared. Gaurav, you have to download. I think there was
Download.
a mail from Professor Swag.
I have, I mean, but then it's only the chi-square and ANOVA code.
Okay, let me.
There's a trailing mail we
Is
have.
it the linear
in the trail mail?
regression?
In the trail mail, you will see this one. In the trail mail, in the same code, in the trail. Shagoto sir forwarded my email as well. See.
Okay,
Okay.
I can see this full data, small data.
Okay. Give me your email ID. I'm sending this to you. Give me your email ID.
Yep. Gaurav. Sharma 2.
Gaurav.
Yeah, this one.
Okay. Take this. Download this. Okay, just open this. I will and open this, and I'm giving you a 4-5 minutes break. But I am assuming that everyone opened the code in Python and then going to take a break. So let's resume at sharp 5:32. 5:32. Now
We only have small data though. We don't have the full data.
Doesn't matter. Doesn't matter. For now, use the small data. Okay. I will use the small data as well for you. Okay. Doesn't matter. So we will be resuming at 5:32, and everyone will be ready with the code open. Okay. And if you are facing any problem in opening the code, you are facing any problem in opening Python, you don't know Python, just let me know. I'll try to solve as much as possible. Okay. So let's take a pause there. Okay. After 5 minutes, we are resuming back. Bye. Yeah, I am back. Everyone is back or hello? See,
Hello, sir. Yeah,
Ashish is
we are
back,
here.
Sayan is back.
Yes.
Okay. Gaurav, Joindro.
Yeah, yeah. Join back.
Okay. William, SVS, Raja Prasad, Malaya, Kitsiri, Samarakun. Okay, let's start. So let's open Python. Already open Python, I believe. So let me do that. Hmm. So first line, we are importing some libraries and extension of libraries, right? The from scikit-learn, we are importing train test plate, logistic regression, reprocessing, accuracy score, classification report, confusion matrix. So for matplotlib, this is some visualization related stuffs. Matplotlib, import pyplot as PLT. It's nothing to do with the model, it's only the visualization for us. And Seaborn is also it's a visualization. Okay. Any question on this block? In this block, any question? Any first block? I executed the first block. Okay, got executed. Now let's take the small data. Hmm? So I executed using the full data. No, I'm taking the small data as well. Let me take the small data. So let us see the data first. Okay, data first. What is the business objective? So first, before starting anything, we need to understand what we are doing, right? So let's understand what we are doing. So this particular data, it's a default data. Like the first example we got in this class, the default data, default. So whether customers are defaulting or not, this is given here, this class. And v1, v2, v3, v4, there are no names. So purposefully, I am using this data. This is a realistic data. This data is a transform data. There are a lot of x variables, name as v1, v2 up to v28. Lot of data which are transformed and processed, and there is an one amount. Amount is a amount. This amount data is raw data, so it's not processed, and this is a class. So in this data, in the small data, if you see, this is my y variable. Class is my y variable. We are going to predict this class, and this v1, v2, v3, v4 up to ad. So we just need to ignore this time. So this is time. Time is nothing but timestamp. Okay. So 00 means 0, 01 means 0, 12. Maybe the second timestamp is termed as 1. The third timestamp as 3, 4, 5, 6, 7. It's a timestamp. Nothing but a timestamp. Okay. So we cannot use this in our as an independent variable. Definitely, you understand. Time, name, these things cannot be predictor, right? So or independent variable. So time we need to ignore. This v1, v2 up to this. This is my uh, this is my v1 v2 up to amount. This is my set of independent variables, and my dependent variable, this is class. Okay, class. So class. So now the first step is to understand the business problem. The business problem, we need to predict this class using these columns. So v1 to amount ad. So first step of machine learning for us is to understand the business problem. Understand the business problem. Understand the business problem. Understand business problem. Okay. Next step is to understand the data. Understand the data. Data means the attributes. Understand the data. So here nothing much to understand. We can at least understand that these are the variables and this time variable we need to drop before prediction. Amount we will be using, and y is my this class variable. Okay, so the next step is understanding the data. So this is also done. Now third step is we need to load this data, right? Load this data. Let us load this data. Just give me a moment. I'm coming back. Yeah, sorry, I'm back. Someone at the doorstep. Yeah. So understand the data. Now next step. Let us open the Python code. We are reading the data, right? We are reading the data. So credit card CSV. Okay, instead of this we need to use the small data. Everyone is using the small data, right? So I am also using the small data. Now after loading the small data, we are dropping the duplicates. So duplicate value will not be any use if there is any duplicate. So this is how we can duplicate the data. So so this drop duplicate is a add-on. It's a property of pandas dataset. So this is called pandas dataset. How you will understand in Python. This is type of df. It's a pandas code data frame. Okay, so here if you make dir, you will be able to see all the columns. Okay, all the everything. If you just put the directory, what in there. See, drop duplicates is a property. That's what you use. Drop duplicate is a property. So there are many things. So using dir, you can see what is possible, what is not possible. It's a huge list.
Duplicate basis all the columns. It's all the rows, as in duplicate basis.
Duplicate basis all the rows. Yes, correct. This is all the columns. Yes. With respect to all the column, we are removing the duplicate. If these two are duplicate, then it will keep one. Duplicate means if there is any difference in any column, it will not consider as duplicate. Okay. It's an identical record. If you have identical record, it is actually removing that.
It's no dupes, as in says.
Okay. Then if it is not duplicate, then the length will be same. Let me tell you length of this. So let me read this again. That we can check as well. Length. Okay. After dropping duplicate, After dropping duplicate, it was 96022. No, there are some duplicates. 9566 decreased.
Yes.
Okay. Okay. So now we are going to drop time. Time is not needed. Definitely, time is a label. It's a time stamp. That's it. We are going to drop time. And after that, we are segregating this y and x. This is my x variables, right? Class is my y variable, and other than the class column, all are independent variable, right? So we are just defining that x and y, nothing but x is my independent variable, set of independent variables, and y is my dependent variable, right? That is what we are going to test. So these are some basic data. These are some basic uh, uh, data management we did, right? Some basic data management. So this is a huge thing. I will term this later. For now, I'm not making this complicated. Just remember comparison in. Oh,
Dropped.
So when we do DIR, we see other things as well apart from the column names. So that's something which this pandas data frame create by its own, or I mean, what they are?
no. See, in Python, any object in Python, if you want to understand what are the possible properties within that object, it's built in within the object. You can use dir the object name. That's it. That's what I. Okay, it's generic. It's not only for pandas data frame. Everything you will be able to see using dir.
But then what's that everything? I mean, so when we see other than column names, so what they are?
Okay. Oh yeah. Other than column, the column names are there. Though it's a pandas data frame, there are some columns.
Yeah.
And
So this
yes,
access and then array
these are some
priority.
properties. These are some properties of pandas data frame. What are the axes? Okay. So not
So
not
these are some variables which
no. These can be. These are some properties. Properties include the sub objects within that particular structure, the functions on top of which we can operate, and this is the extensions. These are the extensions as well. See, and these are the functions you can apply, like apply map, apply, remove duplicate. Okay, these are the things. So you don't need to think about in that detail for now. These are the functions. So in any object, you will be able to see, if you mark directory object name, you will be able to see what can be done with that object and what are
okay.
the sub objects within that particular object. Okay, this can be. So it's not. So if it is complicating thing, then let's leave it for now. Okay. So you can, to drop duplicate, you can use this drop duplicate.
And what says in place equals to true?
In place equal to true, it is replacing it is replacing this df with that duplicated part. So it is dropping duplicates and replaces df object. Df is an object.
Okay,
Df is
basically
a
it
data.
starts storing
Yeah.
it anywhere else, but then removing duplicates from the same data set.
Yes. What it is doing, na? What it is doing, I'll tell you. I'll try to give you an example.
I think I've understood.
Okay. So say for the rest, df is there. It is taking in df1 exactly. In df1, it is removing duplicates and storing in df2, and df2 it's replacing df. Okay, it is copying to something else, and in that copy it is removing duplicate and storing somewhere else, and it is replacing back the df. That's it. Okay, so we are jumping these steps. Basically we are jumping these steps via this in place equal to true. Okay, so x and y and extend. Okay, so some basic data management we are doing. Step number 3. So let me number this little bit. Let me number this. Let me number 1, 2, 3. Okay, anyways, let's use green. Under basic data management, basic data management, number 4. Number 4, we are doing now. These are important steps. This is a very important step. Train, test, split. Okay, you need to understand this. For any classification problem, after this basic data management, we do this step: train, test, split. Okay, so see this basic data management. In this basic data management, I am putting a star. I will explain what is this star later. Okay, this star, I'm putting a star over here. Okay, so train, test, split. So in train, test, split, what it is actually doing in classification problem, we always need to do this train, test, split. Okay, and I'll tell you what I'm actually meaning by that. See, suppose you are creating a model which will predict default of the customer, like this we are solving, right? Default of customer, default will predict default of that customer, loan default of that customer. Okay, 1 or 0. Now you are submitting that model, you are running the model and creating a model, and you are sending that model file to your customer and say that use this as your in your production. It will predict the default, predict default for you. Will the customer trust you? No, right? Because what is the proof? Where is the proof that your model works well or not? What is the proof? How it performs? So before our final secondary examination or higher secondary examination or any exam, we appear for a couple of mock tests, right? We appear for our school pre-test, test and all, pre-test, test, final. Okay, so many exams are there, right? Before our before any final exam. So why those things are there? So test whether we are ready for that exam or not, right? If we are not ready, then we need to study more, and we need to prepare ourselves more, and then go for the final exam, right? Here also the same case. You need to test your model. You need to test your model whether it works or not. Okay, how we can test my model? Test my model, what the model will do in real life. Can anybody answer what the model will do? What is the purpose of this creating this model?
Prediction.
Predict.
To predict. So whether that prediction it is doing correctly or not, that is something we need to test. Yes or no?
Yes.
Okay, so now how we can do that? We don't know the future. In future, which customers will be there, who are they, who all are so we don't know, don't have any unknown data. What we have a huge training data, huge data with us, not training data. So pardon me, so training data, you forget this term, training data. Okay, I am not yet I am not yet there to explain training data. So we have a huge data, right? We have a huge data set, or maybe a data set. That particular data set, may contain 1,000 rows, 1,000 rows. Okay, 1,000 rows. In those 1,000 rows, y is present, because it's a supervised problem, right? Y is present. Y is present. Now to test our model, what we will do, we will divide our entire data set. We will divide our entire data set into two portions. One is training and one is test. Okay, using the training data, so training data means it will have the major portion of the data, maybe 70% of the data or 30% of the data, or 80% of the data will be in training data. 20% of the data will be in test data. Okay, so training and test. So we are partitioning the data into two parts. It's a huge part, it's a small part. We are terming this as training data, train data, and test data. Okay, now let's take a little closer look. Let's take a little closer look. Now this is all data I have. This is all data I have. Right, now in this data, how many classes are there? What it will predict actually? Can you tell me what it will predict? It will predict the class variable, this class, this y variable. Now this particular class have 0 and 1. So now how many 1 are there? 1 means default. How many 1 are there? 492 1 out of 96,000. Can you see this? 492 1, 492 default cases out of 96,000 something, 22 cases. Now I'm filtering out, definitely the rest will be 0. Still I'm seeing 95,530. These are 0 cases. Okay. Actually, I removed duplicate, so that the count will be little bit lesser in both the cases. Okay. So now the point is, if you are partitioning the data in 70 and 80, 70 30, 70 as train set and 30 as test set, or 80 20, 80 as train and 20 as test set, then there is a chance you don't have any one case in your test data. There is a chance, right? Then will that be a fair test? So suppose you have 5 chapters, 5 mathematics chapters in final exam, right? I am designing a test question which only involve 3 chapters, 2 are left. Will that be a good question paper?
No, we'll have to take a random sample so that
We will take random sample, but there is a chance, because 492 is it's a very small amount, right? It's nearly 0.5%, right? In 96,000 it is 492, it's nearly 0.5%. So 0.5%, there is a chance that if you are taking doing 70 30, all those 0.5% going into your training set, and no example, or very less amount of example, maybe 5 6 examples are only going into your test set. So that will be a good partitioning. What do you think? That will be a good test set.
no, it will not be a good test set.
Yeah, the scenario I just mentioned, you have 5 chapters in your final exam. I am creating one question paper which involves question from only 3 chapters, and you performed well. You scored 98 out of 100. Does that mean you will score well in final exam? No, because basically you skipped those 2 chapters and by chance you got lucky. I in my question I also skipped those 2. The test is not proper. In final exam you are scoring 65. Why? 50% or 40% of the question came from those 2 chapters which you completely skipped. Right? This thing happens for the model as well. The model needs to see all the cases for training, and model should be tested in all the cases in test set. That is how it should work. This is very intuitive. Now let me know if you understand or not. This is important. Hello.
Yes, sir. Yes, sir. We do understand because the model needs to see both the cases. Otherwise,
Yes,
it will
both the
not be
cases
training.
in proper proportion. That's right.
Yes.
Now let me just give me a moment. Sorry. Now let's understand this first minutely. See, df df is look like this. This is 0 and 1, right? 0 and 1 you have. Now df dot class, df dot class is this. Now dot sum means 473 cases 1, right? 473 1 cases, 473 cases 1, and df dot class, oh okay, sorry, length of, now length of df minus 473, how many? 95 163, 95 163. So instead of, I was thinking that I will do this in Excel, but anyways, so you are understanding. So don't think about the syntax you will learn in Python. You will learn syntax any day. Is there? So programming is not important. The important is concept. This concept is evergreen. You will need this everywhere. So 473 1 cases and 95 163 0 cases, 0 cases, right? Now what is the proportion? The proportion is 473 divided by total. Total, what is the total? Length of 9563. Oh,
DF,
df, sorry,
DF.
df, length of df. This is nearly 0.05%, right?
Enough bad to, not enough to train.
Yeah, yeah. No, you cannot say that not enough to train, but we need to see that whether it's we are able to train this or not. That's a different question altogether. But it's a very, so in real life case you will get that much of fraud, that much of default in real life case. Okay, so it cannot happen that 30% fraud or to 40% fraud or 50% fraud or default, right? It will be very low. It is little low. This is really low, but this is a real data. Okay, in real data we are getting this. That means this is what we have. On top of this, we need to work. So now, so 473 95163, this is done. Now I will tell you train and test criteria. So suppose I have in total in entire data, I have this is my data. In my data set, just try to understand this. In my data set, I have 10 examples. I have 10 examples. I have a data set. What happened? I have 10 examples. I have 10 examples. 10 examples. It is x1, x2. This is my y. You know, 1, 1, 1, 1, 1, and 0, 0, 1, 1, 1. Okay. Now I am creating a data set. 90% will be my training data, and 20%, 10% will be my test data. Okay. So 90% will be my training data, which is completely unseen, which is completely different from this 10%. 10% is completely unseen. So this is my training data and this is my test data. So we need to create, what is the proportion over here? Proportion is 20 is to 80, 8 1 and 20 zeros. So we need to create this 90% in such a manner that 20 is to 80 ratio remains there as well. Okay, so that means here we will have, you will have, so if it is 90 10, then 90% 10%. So let's So 0, another 0, another 2 0 I am putting. Okay, another 2 0 I am putting. Otherwise, the example will be a little bit difficult to understand for you guys. So 4 is to 6, right? 1, 2, 3, 4, 5, 6. 4 is to 6. This is 4 is to 6 or 40 to 40 is to 60. 40 is to 60. 40 is to 60. Now you need to divide your data in such a manner that this 40 is to 60 percentage remains in training set and test set as well. Okay.
So I have a doubt.
Yeah. Tell me.
Yes, what is this the initial x1, x2, y that you have created apart from the training and testing?
Okay. This is this. No. Initial training test. No. So let me extend this little bit. This is my entire training data. This is my y column. This is my entire training data. Let me extend this. This is my entire training data. Not training data. This is my entire original data.
Data. Okay.
This is my x space and this is my y. This is my y. Okay.
Yes.
Okay. So now, so 90% data. So here I am. What I am doing? I am trying to create a training set. See, I am trying to create a training set. Don't get confused. Actually, I am just taking the example. I am trying to. This should be 80%. This should be 80%. So training set will be my 80% training set, and test set will be my 10%. 20%, sorry, rest 20% test set. Now 80% data and so how many in 80% data? 80% data, that means total number of observations will be 8 over here, right? And here total number of observation will be 2.
Yes.
Right?
Yes.
So for this we cannot break. So here 40-60% ratio we need to maintain. 40-60%.
This 40-60 percentage of Y's, right? Number of Y's, I mean, in both the classes.
Yeah.
Yeah, but in our data, we have seen that it is around 95 and something.
Yeah.
Very...
Yeah. In our I'm giving this as an example. So you need to create a 10 test set in such a manner that is 40-60% persists. This 40-60% proportion remains.
Okay.
Oh, this 80-20 is nothing but your training and test proportion, total data. So 8 data point and 2 data point. Within 8 data point, you have to take maintain this 40-60% ratio.
Okay.
40-60% ratio. Let's give you a proper example then. Okay. Let's give you a proper example. So you have 100 data. In 100 data in y variable, you have 21 and 80 0. Okay. Now in 100, in this 100 I am splitting into 80-20. 80% will be my training data and 20% will be my test data. Okay, this is my training data, this is my test data. Okay, so this, let's make this 30-70, otherwise you will get confused. These are different proportions. Let's make this 30-70. Now I will ask everyone. So now tell me, is this clear? This is 30, this is 70. Total amount of data is 100, and y variable has 31 and 70 zeros. Now from this 100 data, I am trying to segregate 80% train and 20% test. Okay, 80% train and 80%, we should have this 30-70 ratio, 3:7 ratio. 3:7 ratio, and 20% should have 3:7 ratio, right? So now in 80%, how many 1 will be there? That's my question. So 80 into 3/10, right? That will be number of ones. That means 24. 24 1 will be there, and 80 into 7/10, 56 will be 0. 56 0 and 24 1. Okay. And here if you can see, so total number of 31 one is there, so 31 is there. How much is remaining? 6, 6 1 and 56 minus 14 0, 14 0. Okay, now let's see. So here 3 to 7 ratio is getting maintained. Let's see here it is maintained or not. Then 6 by 14, it is 3 by 7. 3 to 7 ratio is remaining. So now this sample is worthy to create a model, and test a model, because this ratio is remaining in the train and test set, not only in the original data. Okay, this entire process is called stratification, stratified sampling. This is called stratified sample, stratified sampling. This is called stratified sampling. Okay, now, so you don't need to do that much of calculation. Okay, so I tried to make this easy, so that's why I tried to explain in that manner. So hope that helped. Now see this x train. So this is the line where it is basically splitting x and y in train and test, and test side is 0.2, that means 80%, and train test split is with nothing but it is stratifying the thing. So you don't need to, it will automatically take the proportion of 0 to 0 and 1, and it will create train and test set in such a manner so that the ratio of 0 and 1 remains same with the larger set. In that manner, this is train test split. This is part of psychic learning. This is train test split. You don't need to, you just need to run this line, that's it. Okay, yeah. After that we are standardizing. This is a standardization thing. This is for logistic model, this is optional, but if you do standardization, it will make the process little faster. Okay, standardization is nothing but this process. Standardization means 1 2 3 4 5. These are my, suppose this is one column. So standardization is nothing but what is the average of this entire thing? Average is 5, average is 3, and what is the standard deviation? The standard deviation may be 2, right? Okay, anyways, let's min max. So you need to calculate the, so this is one kind of standard normalization. This is called x minus mean by standard deviation, and another is x minus minimum divided by maximum minus minimum. This is another
So,
kind of standardization.
so the first one is Z scores.
Yeah, Z score, correct. Normalization, yes. Standard normal distribution is so Z score is coming from standard normal distribution. This transformation is similar like that, just like that. Okay, and this is mean max standardization. This is normalization. Okay.
Sir, why is it required?
Yeah, this is required for better processing for the model. This is optional for logistic model. It's not fully needed. Okay, and this is required, this is primarily required for distance based algorithms like k-means clustering, k nearest neighbors, those things. Distance based algorithms, this is needed, where you are actually basically calculating the distances between two variables. So this is optional, this part is optional. You may skip this. Okay, you can directly use x instead of x train scale. Okay, and after that what it will draw a histogram with distributions of all the variables. So all the x variables it will take in, and it will create histogram for everyone. Histogram, this is just distributions of the variables. Okay, this is a code piece. And here you can calculate the correlation of each and every variable. So you know correlation already.
Yes, yes.
Okay, so this is correlation matrix. This is plotting. This is simple correlation matrix. It is plotting. Okay, these are part of feature engineering. Feature engineering is nothing but I mentioned three steps, right? First step is understanding business problem. Just give me a moment. Understanding business problem. Understanding business problem. This is first step. Second step is your data management. In data management, these feature engineerings are needed. The data management, I put a star. You remember? So these are feature engineering part of feature engineering is part. This is called feature engineering. So which particular variables are linear among themselves, collinear among themselves? We can drop those features. So there are some things. So if there are some missing value, we can impute those. If there are some outliers, outlier means which are not in range. So extreme values basically, not in range, not realistic. So we can impute those or we can remove those outliers or impute those outliers. These are part of feature engineering. These are part of data management, and this particular discipline is called feature engineering. Okay, so we will slowly learn this thing. So the next step is load data, and next step. Okay, sorry, data management. Before data management, load data, train test split. Sorry, train test split. Train test split. After train test split, model and then test. Okay, so now all you need to do, you need to run these two lines of code to create your logistic regression model. Okay, so this is the train data, and this is y train. So x and y you need to mention. X is the collection of your x variables, and y is collection. Y is not collection, y is a single variable, single y variable, right? So model fit this, and it will create a model in this model variable. Okay, okay, now train accuracy. This train accuracy is extra wide train. So this is accuracy in training set. Accuracy in training set is very high, 99.78%. Now I will discuss one important thing before closing this call, closing this session. That is very important. You need to concentrate last 10 minutes. Okay, it will take 10 minutes, but this is very important. This is also like train test split. This is important for each and every classification, like testing or validating the model. Okay, testing the model, testing testing classification models, testing classification model. So see, this test is there. So that scalar transformation we are doing over here, the same transformation we are doing over here, and we are predicting using the model variable. So let's see what is in model. Just entering model. See, this is a logistic regression. Okay, so now we are predicting the model using this particular function extension model.predict, and what we are providing, we are only providing the x variables. And after after providing those x variables, what we are getting, let's see. These are the values we are getting. Basically, intermediately it is providing some probability. On top of those probability, it is ranging. If it is greater than 0.5, it is predicting as 1. If it is less than 0.5, it is predicting as 0. Okay, and which is not standard. So nobody told us that 0.5 is the 0.5 is the optimum cutoff for the probability, but we are assuming this for now to find out the optimum cutoff. That may be 0.49, that may be 0.37, that may be 0.75 as well. If it is greater than 0.75, we can predict that as 1. If it is less than 0.75, we can predict that as 0. But we need to find out that optimum cutoff, that particular optimum cutoff finding out that optimum cutoff needs a separate study. It is called ROCR analysis. ROCR analysis, receiver operating characteristics analysis. Okay. ROCR, ROC curve or something like that you might have heard, but that is a different analysis. So for now we are assuming 0.5 and using that 0.5 cutoff, we are getting this array where it is predicting 0 and 1. Now test accuracy. This is the most important thing. Test accuracy. What is the test accuracy? Test accuracy is also 99.79, but this is basically not the real picture what we have. Okay. So now I will tell you how this is actually tested. So I will suppose in our example, in our example there was 24 1 and 56 0, right? And in train set, and it was 14 1, no, not 14, 6 1, 6 1 and 14 zeros. Right now I am predicting this particular, I am putting the x for these variables, x of this test data to the model. First I am creating a model out of this train data model, and I am providing the input x of this test data, x variables, and it is giving me one y variable. The model is showing me predicting one y, and this y is predicted y, right? This predicted y we are comparing with this actual y, this 1 and 0 actual y, this predicted y. So how many predicted y will be there? 14 plus 6, 20, 15, 20 predicted y will be there, right? So something like this, y, something like this. So let's do this in Excel now. Okay, suppose for our example only. Okay, so this is my actual y, actual y, and this is my predicted y, okay. Now is it visible, my Excel file?
Yes,
Yes,
sir.
it is.
And between okay, and predicted y is, oh okay, actual y I should 14.6, right? 15. This is very important. Okay, just hold on. I understand that your class we are overrunning, but this is important. Oh, it's the reverse one. Sorry. 0. This is 1. This is 1, and these are my predictions. Okay. Let me fix this. Okay. Now tell me true or false. Is it correct or not? Correct or not? Not. So if these two are matching, then this is correct. Okay. If these two are matching, this is correct. Then what is the correct? What is the accuracy? Accuracy is true. True is 13 out of 20. 13 out of 20 is correct. 13 out of 20 is correct. Now I will see within 1 how many correct. I am filtering out 1. I am putting this within 1 how many correct. Total 1 is 6. Total number of 1 is 6, right? And within 1 how many are correct? 5 correct, right? I'm writing this here. I'm writing this here. Now I will see within 0 how many are correct. Within 0 how many are correct. 8. Within 0, 8 correct. Within 0, 8 correct. Now this 5, I'm writing this here. 8. 8. 8. Okay. Okay. Now within 0 how many are wrong. How many are wrong? 6. 6. And within 1 how many are wrong? False. 1, right? False. 1. I'm writing this here. Now I'm labeling this actual, 0 and 1. I'm merging this cell, centering, and this is 0 and 1. This is my prediction. This is my prediction. This is my actual. These are my number of. Okay. Actual and prediction row wise. So out of total actual, how many 0 has been correctly predicted? Actual is 0 and prediction is also 0. How many? 8. Now tell me, actual is 0 but prediction is 1. How many?
6.
6. Now tell me, prediction is 0 and actual is 1.
1.
1. Okay. And actual and prediction both are 1 is 5. Right? Okay. So this is called confusion matrix. I'll not confuse you anymore. So you read this confusion matrix. What is confusion matrix? From this confusion matrix, two things are important. Two things. See, true positive rate, false positive rate, those things I am not teaching you now. Okay. You will learn that. I like to teach which one is your important class. Now you ask your business that which one is your important class. You tell me in this problem which one is my important class. Detection of this should have business impact. So which one? Obviously the rare class, na? Rare class. The rare class means the 492 over there. 492 over there. And here this one. This is the rare class. So for rare class, two things we need to see to check whether this is working fine or not. First, total actual rare, how many correctly predicted among total actual rare class? How many correctly predicted? 5. Out of 5 plus 1, 6. 83% is total rare. This is called sensitivity of the model. This is called sensitivity of the model. This is very important. See, I am saying what is used in practical. So in books, you will have millions of blogs and all where you will get explanation for confusion matrix. But this is something in practical we see. The rare class is one that is most important, because if we say all 0, see, if we say all 0, correct, another model I am creating, it is predicting all 0 model. all zero model. Okay. So in all zero model, if you see, all zero means in all zero model accuracy. Accuracy is this equal to actual, right? So now see the accuracy 2 is 14%, which is more than this basically. See the accuracy is how many predictions are matching irrespective 1 or 0. 14 by 20, 14 by 20 means 70%, but it doesn't have any value, this particular model, because it is unable to predict the class 1, the rare class. Okay, the rare class you need to see whether it is predicting correctly or not. Automatically the popular class prediction will be high, prediction accuracy will be high. That is the thumb rule. Okay, for binary classification at least. So to conclude, this is sensitivity 83%, and another thing, precision. Instead of that, I could have said all one, na, all one. Then this will be a problem. Then that will be a problem as well, because instead of pointing out the fraudulent or default persons, you are saying everyone will default. Then your business will be confused that how they will manage if everyone model is predicting everyone is will do default, and in reality that is not the case. Then that will be the cost issue for the organization as well, that everyone is default for each and everyone. We are not giving, we are providing a cover on the loan, we are not providing loan. It's not gonna happen, right? It's not a realistic issue. So that's why we need to see another metric. Among the predicted rare class, how many are correct? How many predicted rare class? How many predicted rare class? The model, by the model, there are how many predicted rare class are there by the model? Say 6 plus 5, 11. And how many are correct? 5 is correct. Then again 5 by 11. 5 by 11. So this is called precision.
Sir, is there something called as specificity?
Yeah, specificity is there. Yes, specificity is nothing but it's accuracy of the zero class. So see, there are different names. Specificity, recall, different book have different things. So someone will say specificity is one class accuracy of this class. This one is called specificity. Someone might say as well. Okay, so we usually follow the thumb rule that zero, accuracy of zero, that the popular class will be accuracy of the popular class will be specificity, and accuracy of the rare class will be sensitivity. And we see the precision of the rare class. Precision is total predicted will be in denominator. It's very easy. Total actual, so always rare class correct will be in numerator. Correct prediction in rare class will be in numerator. What is my rare class? 1. What is the correct prediction count? 5. So 5 will be always in the numerator. If it is sensitivity, you need to give total actual rare, that means 6. If it is specificity, you need to give total predicted rare class, that means 6 plus 5, 11. This one, that's it. 5 by 11, that's it. Okay.
But yeah, so,
Yeah.
but in this we did not understand. So which is, so all of the variables, so 28 plus 1, 29 variables have gone into this model, and which got dropped.
So this is an example. I didn't run that code. I will run that code now. See, screen confusion. So all the things. See, this is the confusion matrix. Same thing. Now you will be you will able to understand. This is actual values. 0, 1900, 19025 predicted correctly for 0, and 8 predicted incorrectly for 0. And for 1, 31 predicted wrongly and 64 predicted correctly. This is the confusion matrix. for this?
No, so earlier when you used to do logistic regression, you would have information value or the variable, so you will do a variable elimination or something like that. So you'll have a long list, a short list, right? So here, all the variables have been taken into account. So none of the variables have been dropped.
Let me give you. So those are part of C. So I didn't cover those part. I covered the basic thing. Now that is part of feature engineering. Okay, that is part of feature engineering. So though you brought this point, I will answer your question. Apart from that, if any question is there, just let me answer, and then I will let the class go, and I will answer your question. Okay. So because
So you can,
yeah,
in the confusion metrics created for this thing, can you tell all the specificity, precision, and so that it goes?
Let me calculate. Sensitivity. Okay. What is CM? Let me print this CM. This one is CM. CM 1 is 64. Sorry. CM now CM 00 is my this right. Now sensitivity is nothing but, so how many? So this will be numerator of sensitivity, you know, because a correct prediction of 1, right? You can see this. Now total one. How many total one are there? Total one. So how many? 0 1. Sorry. 1 0 1 0 1 0. Now sensitivity will be total predicted sum of total predicted 1 plus okay. I'm sorry. I put a plus. Still, I'm providing that sum operator. Now, 67% sensitivity. Now, specificity will be similarly 64 by 64 plus 8, 64 by 72. Sorry, precision. 64 by 72 will be your precision.
So maybe we have to look at both to understand the business implication. I think we have to look at this true positive, false positive, because it makes a lot of sense.
Yeah, true positive is nothing but sensitivity.
Yes.
True positive rate. It's a different name. I told it's a different name. Okay, so for now, let's see. Confusion matrix confuses people. The confuses beginners.
Yes.
So for now, you need to understand what you need to see, don't need to see. So basically, one thing is complementing others. So if you are seeing sensitivity and precision, automatically the other things will get noticed. That's the idea. Precision I will calculate for you. Precision. See, numerator will be same. 0 1. Precision is now. Precision will be high, 88%. Okay, so now any question in confusion matrix? If not, then I will answer that question, and whoever is not interested, then they may drop off. I will answer that question, that information value, AIC, VIC, those things. Any question in confusion matrix or whatever we covered in the class? Do practice. This is basic of classification. This plain test split and this confusion matrix thing. Don't forget these two things. These will be your bread and butter for classification modeling. Any question?
Okay, so I'm just trying to understand the implication of this.
Okay, implication means?
In the sense, okay, we have trained the model,
Okay.
but uh, mm, we did not generate any prediction from here, right?
Yeah, it is generating prediction. Yes, it is generating prediction. You need to invoke in this manner. This model
Okay.
dot predict invoking, and you are providing any x value. It will
Okay.
provide you the prediction. But x
Okay.
value should be like trained data. Should be like
Okay.
trained data. You cannot supply two v1 and v2 and you cannot expect prediction. It will fail.
Okay.
You
So
have to provide all 30 variables information and it will give you the prediction one on two.
so if I want to use it, I have to invoke this
Yes.
function and put the data.
Yes. Later you will be able to save this as well. So some
Okay.
homework I am putting how to save this model. It's a very simple thing. You just Google it and you will get. Let me give you some homework. How to save a logistic model in a file and load it back from disk and generate prediction. This is one example. This is one homework. I'll email this. Any other questions? Okay, so who asked that information value question? Can you give your name?
Sandeep.
Sandeep.
Yes.
Okay. Yeah, Sayan. So we covered the basic outline of logistic model. So before that,
So basically, my question is that matlab in earlier this thing. So for running a logistic regression, you would actually get a long list of variables. Then what you will do is try to find out which variables to go in, right?
yes.
For a logistic model, it was seen that 4 or 5, 6 variables. That is what you sort of included in the model, and the rest all you discarded. Basis a lot of information value mostly, right? So for this model, we have inputted around 28 variables. Now, do we get output which are the variables which are actually coming as significant?
No. We will get definitely, but this is not the best approach to create model. Okay, so this is not the best approach. Best approach, you need to find out the important variable identification. Let's take a step back. So first, we need to understand the business problem. Understand business problem. Understand data. Then data management. Mean data management first. Feature engineering. Feature engineering is nothing but finding out important variables.
Yes.
Finding out. It is in core. Finding out.
So you will do that multicollinearity, PIF, variable inflation factor, all those things, and sort of try to if you can remove certain variables.
Yeah, definitely. So VIF is a different thing. VIF we use to remove multicollinearity from the
Yes.
X space. Okay, it's not used here. So here in logistic model we use information value. You are right. Information value IV.
Yes.
It is a weighted sum of all the weight of evidence of the classes of all the variables. Okay, information value number one, and number two, it's a very important thing, that is Akai information criteria based, AIC based, stepwise modeling.
Okay.
Stepwise. It is nothing but AIC. AIC is a value. It's a coming from the likelihood. Okay, AIC is a value coming from the likelihood. More AIC is worse. Lesser is better. So suppose two models I am creating using V1 and V2. I am creating one model with AIC 200, and I am creating another model V1, V2, V3. Now AIC is 200, 198. So that means this model is better than this. This model is better than this model. This is better model. V1, V2, V3 is better model than V1, V2. Understood?
Okay.
Okay, yeah, I see. So using a stepwise, there is a stepwise technique for this. Stepwise technique means
That
there are,
variables come
yeah,
in and matlab you can remove variables one by one, or you can include variables one by one.
good. If you can remove variable one by one, then it will be, yeah, top down. It is a backward elimination.
Backward.
If you are keep on adding based on AIC, that will be it's a forward addition basically. Okay, backward and forward. Okay.
This was there, but this stepwise function is there in I think SAS for logistic.
Yeah, here in Python everything is there. Don't worry.
Okay.
Everything is there in Python. Everything is there. Python is much richer.
Yes, that is good.
Okay. Hope I answered your question. Any other question?
No, fine. Okay.
Okay. Okay then. Okay then. Thanks everyone for joining in. Thank you. Thanks for your time.
Thank you. Thank you.
Okay. Bye.